Hello, my name is Ekram Nia, and I'm going to explain the Rasp robot. The mechanical parts used for this robot are the added motor head, one Raspberry Pi camera, audio storage module, LED modules, tracking module, servo motor, servo gear, tracking battery holder, and Raspberry Pi. And also the other parts are made of the acrylic plates. The method for using this robot was first install compatible versions of Python, OpenCV, and NumPy, and then download the Raspberry Pi user and mobile system software to be connected to the Raspberry Pi. We connected the Raspberry Pi to the Wi-Fi using the Azure Secure Shell, and also we wrote a program to set the servos to the 0 angle before installing them into the mechanical parts. After that, we assemble all the mechanical parts, we ensure the functionality of the electronic parts, and we install the electronic parts inside the mechanical parts, and then we connect it to the Raspberry Pi using its IP address. Then we uploaded the Python codes from the GitHub, and we run those GitHubs in the mobile external software which enable us to edit them, so we had a bit of functionality for the robot. And also, we opened the robot via adding web controller to be able to control the robot. The first usage of the robot was pick and place. The robot can move forward, back, or left, or right. Also, the robot can go up, down, left, right, grab, or loose. Camera can move up and down, and we use these functions to pick and place the item in the designated place. For controlling the motor, if its value is 1, it's moved forward, and if it's -1, it's moved back. But for moving forward, this motor needs to be 1 for both of our motors, and if one of them is -1, one of them is 1, the robots will go left or right. Also, for the servo, we have a value which is usually 150 to like 500, that sets an angle between 0 to 180 for rotating the servo, and the frequency used for servo was 50 Hz. For the motion detection of the robot, we get the camera picture, we use the OpenCV processing codes, which in this case was CV2 background subtractor with an improved adaptive custom mixture model for background subtraction that can get the motion of the object from the background, and then it draws a line around the moving object and display the video. The final one is the color tracking. First, it takes the picture from the camera. We take the color we want, and first the camera picture is converted to the HSV, and then that HSV image is compared to the HSV colors in the OpenCV. After we realize which function we want, we set the center of the camera to the center coordinate of the detected color.